Zeno's paradoxes are a series of philosophical problems created by the Greek philosopher Zeno of Elea. They are mostly questions attempting to prove that motion is an illusion. This is often achieved by Zeno using problems that have infinitesimal components, and therefore his paradoxes highlight some common misconceptions surrounding the field of calculus. The most famous of these puzzles include the dichotomy paradox, the Achilles and the tortoise paradox, and the arrow paradox. Let's take a closer look at the Achilles and the tortoise paradox. Suppose you have the hero Achilles taking part in a foot race against a tortoise. Achilles moves 2 units per second, while the tortoise moves 1 unit per second. The tortoise is 6 units ahead of Achilles. The question is, will Achilles ever catch the tortoise? This might seem like a dumb question. After all, it is obvious that since Achilles runs faster, he will eventually overtake the tortoise. With a simple calculation, we can show that Achilles will catch the tortoise at time 6, when they are at 16 on the number line. But Zeno frames this problem in a unique way, and perhaps will make you question your intuition. Let's reset the problem here. Instead of simulating the problem out, let's progress through the problem in steps. Specifically, let's stop the simulation every time Achilles catches up to where the tortoise was. Since the tortoise has a speed of its own, it would have moved forward a bit every time Achilles does so. As such, we can conclude that Achilles will never catch up to the tortoise, because there will always be a small bit of distance between them. Are you convinced? Obviously, this conclusion is wrong, based on our experience in everyday life. But can you figure out where it went wrong? Pause the video and have a go at this problem. Let's repeat Zeno's setup, but this time let's run it a few more times, and record the length of the distances between Achilles and the tortoise. We see that every iteration, the distance grows increasingly smaller. If we were to write out this relationship, we would say that as the number of iterations approaches infinity, the distance approaches 0. Note that when the distance is 0, Achilles catches up to the tortoise. Thus, we can restate this as the number of iterations approaches infinity, Achilles approaches to catching up to the tortoise. Therefore, to disprove the conclusion of this paradox, we need to prove that this infinite number of iterations is achieved within a finite amount of time. If so, then in a finite amount of time, Achilles catches the tortoise. Now, take a look at the time value after every iteration. The time value keeps increasing, but never reaches 6. We can say that as the number of iterations approaches infinity, the time approaches 6. Thus, we can say that an infinite number of iterations occurs within a finite amount of time, in this case 6 seconds. Therefore, Achilles does catch up to the tortoise. The problem with Zeno's argument is that by looking at the problem through the prism of these steps, he constrains us to points in time before Achilles and the tortoise converge. The infinite number of iterations distracts us from this fact. The key to the problem here is to recognize that the sum of an infinite number of things, in this case the time of each cycle, can in some cases converge to a finite value. This is a concept that is used commonly in calculus. Take, for example, integrating to find the area under a curve. In this situation, you sum an infinite number of tiny slices to get a finite area. Okay, thank you very much for watching. Hopefully you learned something about the Achilles and the tortoise paradox, and about the nature of infinite sums in math.